Hey everyone, and welcome back to AI Paper Podcasts. We're diving into a paper today called RoseRAG, Robust Retrieval-augmented Generation with Small-Scale LLMs via Margin-Aware Preference Optimization.
Quite a mouthful.
It is quite a mouthful. But the paper really caught my eye because it's all about making smaller AI models just as powerful as their larger counterparts.
Yeah.
And I think that's something that a lot of people are interested in.
Yeah, absolutely. This paper is from a really great group of researchers. They're from Purdue, Rutgers, Emory, Georgia Tech, and SUNY Albany. And they're tackling a very big challenge in AI right now, how to get those smaller language models, or SLMs, performing just as well as those big, huge, resource-hungry models we hear so much about.
Right.
You know.
Yeah, and for our viewers who are just tuning in for this short-form version, here's the quick takeaway. This paper introduces a new framework called RoseRAG that makes smaller language models smarter and tougher when they're dealing with external information. It's like giving these models access to a massive library, but instead of just getting lost in the stacks, they can zero in on exactly what they need and explain their reasoning like a seasoned pro. And the secret sauce, it's a three-step process. First, RoseRAG uses something called rejection sampling to help the AI weed out bad logic or faulty logic.
Right.
So they're not just memorizing facts, they're actually learning to think critically.
Exactly.
Which is huge. Second, it focuses on the AI's aha moments. You know, those moments where it was almost wrong.
Right.
And those uh-oh moments where it was way too confident but totally messed up.
Yeah.
These are gold mines for learning. And finally, RoseRAG uses something called margin-aware preference optimization, which sounds super complicated.
It does.
But it's basically a way to measure how well the AI separates good reasoning from bad reasoning. And by minimizing that measurement, minimizing that loss, RoseRAG basically pushes the model to become a sharper and more accurate thinker, especially when it's dealing with messy, real-world data.
And it works incredibly well. They've tested it, and the results are really exciting.
Yeah, the results are really amazing. RoseRAG actually outperformed existing techniques across a bunch of different data sets in SLM architecture. So this is a big deal.
Yeah.
This could be a game changer for making really powerful AI accessible on everyday devices, like your phone or your laptop.
Exactly.
So it's opening up a whole world of possibilities. All right, now back to our deep dive.
Yeah.
What I found really interesting was that they specifically focused on retrieval-augmented generation. We call it RHAG for short. It's like giving these smaller models a cheat sheet. They get access to this massive external knowledge base to help make up for their smaller size. But the real challenge is making sure they use that information effectively.
Right, and that's where RoseRAG really comes into play. The authors have developed this three-step framework that seems to be remarkably effective. The first step is what they call preference data generation. And that sounds very technical, but essentially what they're doing is they're getting the AI to explain how it's reasoning. So imagine the AI is working on a problem and it has to write this little mini essay to justify its answer.
Okay.
Citing evidence from that external data, like writing a little research paper.
Okay, I'm following you so far. But how does the AI actually learn to do that? Like, does it need a teacher model to kind of show it the ropes?
Well, that's the cool thing about this. It doesn't. They're using something called rejection sampling to filter out any bad logic. So the AI, it generates an explanation and then tries to answer the question based on just that explanation. If it gets the answer right, if the answer lines up with the ground truth, then they keep the explanation. If not, they check it.
Okay.
They reject it. So they're really only keeping the explanations that lead to the right answer.
That's pretty clever. But wouldn't that be super time-consuming, though, especially if you've got a massive data set?
That's a really good point. But keep in mind that we're working with smaller language models here. So the cost of computation is actually much lower than it would be with those giant models. And the authors have actually gone to great lengths to optimize that whole process to make it as efficient as possible. And the results, they really speak for themselves.
All right, you've convinced me. So the AI is generating explanations, the bad ones are getting tossed out. What's next?
Okay, so the next step is what they call contrastive preference data selection. And this is where it gets, I think, really interesting.
Okay.
They're not just grabbing explanations at random from all the good ones. They're looking specifically for two types of examples. First, the ones where the model was super uncertain but still got the right answer.
Okay.
And second, the ones where the model was extremely confident but ended up being wrong.
So it's kind of like, let's look at the near misses and the epic fails.
Exactly.
I love it. Why is that so important?
Because they're trying to teach the AI how to tell the difference between good and bad reasoning. And by focusing on these two extremes, they create this training set that highlights those subtle differences. It's like they're saying, hey, you barely made it in this one, but over here you were way off. What's the difference?
Ah, so they're helping it learn from its mistakes and its close calls.
Exactly.
That's really cool. But are there any downsides to that kind of approach? Like, could focusing on the extremes make the AI miss some of the nuances in those examples that fall somewhere in between?
Yeah, that's a great question, and it's something the researchers actually address. There's always the risk of overfitting when you narrow your focus too much.
Right.
But in practice, they found that the benefits of this targeted approach really outweighed any of the potential risks.
Okay, I can see how that would make sense. So we've got the AI generating explanations, filtering out the bad ones, and then zeroing in on the most informative examples. What's the final step?
Okay, so the last step is what they call margin-aware preference optimization. This is where all the learning magic happens. And they're using a special type of loss function for this. It's called ORPO.
Okay, I've heard of loss functions before, but can you break down what ORPO does and why it's so special?
Sure. So ORPO basically pushes the model to become a sharper, more accurate thinker. It does this by widening the gap between what the model sees as a right answer and what it sees as a wrong answer.
Got it. So it's not just about getting the right answer. It's about being really sure that the answer it chooses is the best one. It's like the AI is getting more and more confident in its decisions.
Exactly. And that means that it performs better, especially when it encounters information that's ambiguous or kind of noisy.
Okay, that makes sense. So they're not just feeding the model answers, they're actually teaching it to think critically and justify its choices.
Exactly.
That's pretty impressive.
Yeah.
But I think our listeners are probably wondering, does it actually work? So they put RoseRAG to the test, right?
They did, and the results were really impressive. They tested RoseRAG on a bunch of popular question-answering data sets, things like Hotpot QA, 2Wiki Multi-Hop QA, and Strategy QA, and they even tried it with 3 different SLMs, Quinn, Llama, and Gemma.
That's a great point. Trying it on different SLMs shows that this isn't just a one-trick pony.
Right.
It works across different model architectures.
Right.
So how did it do? How did it stack up against the competition?
It really blew the competition out of the water. Across all 3 datasets and all 3 SLMs, RoseRAG consistently performed better than all of the other RAG techniques that they compared it to, and sometimes by a significant margin.
Wow. That's pretty amazing. And they achieved all of that using smaller, more efficient models. That's a pretty big deal for the future of AI.
Absolutely. And we're going to dive into those implications in a bit. But first, I think we should take a closer look at the results on each of those data sets. Each one has its own unique challenges, and it's really insightful to see how RoseRAG handled them. What do you say we start with Hotpot QA?
Sounds good. Let's dig into Hotpot QA and see what makes it so special. Okay, Hotpot QA. Now, from what I understand, this one's all about something called multi-hop reasoning, which sounds like a move from a sci-fi film.
It does sound a bit futuristic, but actually it's a pretty practical concept. Multi-hop reasoning basically means that the AI has to connect the dots between different pieces of information to answer a question.
So it's not just about finding one single fact. It's more about putting together information from multiple sources and figuring out how those pieces relate to each other.
You got it. And Hotpot QA really pushes those reasoning abilities to the limit.
Okay.
It uses Wikipedia articles as its knowledge base, and the questions they use, they often require the AI to jump back and forth between different parts of an article or even between multiple articles to find the answer.
So it's testing the AI's ability to follow like a breadcrumb trail of information and make connections.
Yeah, it's like a treasure hunt.
Exactly. That sounds pretty challenging.
It is, definitely. So how do you think RoseRAG did on this obstacle course?
Well, you told me earlier that it did really well, so I'm going to guess that it aced it.
You're absolutely right. The results on Hotpot QA were really impressive. RoseRAG consistently outperformed those baseline models, and in some cases, it even achieved state-of-the-art performance.
That's incredible. But what was it about RoseRAG that allowed it to do so well in this multi-hop setting? Was it the rejection sampling, the contrastive selection, or the ORPO training? Or all of the above?
You know, it's really a combination of all 3, but I think the contrastive preference data selection really played a crucial role here.
Okay.
Remember how they focused on those examples where the model was either very uncertain but correct or super confident but wrong?
Right, yeah.
Well, by doing that, RoseRAG was really able to learn the subtle differences between strong and weak lines of reasoning.
Oh, I see. So it's like those examples help the AI develop a much deeper understanding of what makes a valid argument, especially when you're dealing with information from multiple sources.
Exactly. It's like learning to spot the fake news from the real news. It's all about building that intuition for what makes a solid argument even when the evidence is scattered all over the place.
Right.
And that marginal aware optimization with ORRPO, well, that just took that learning even further. It pushed the model to be even more discerning when it's making those choices.
That makes sense. So HotPot QA showed that RoseRAG can definitely handle multi-hop reasoning.
Yes.
But what about 2 wiki multi-hop QA? I know you mentioned this one uses a different kind of knowledge base.
It does. Instead of using those Wikipedia articles, 2 Wiki Multi-Hop QA uses Wikidata.
Okay.
Now, Wikidata is a massive structured database of facts and relationships.
So it's less like a collection of articles and more like a giant knowledge graph.
Exactly. It's a whole different ballgame.
Does that change how the AI has to approach the task?
It absolutely does. You see, navigating a knowledge graph requires a different set of skills. It's all about understanding how entities and concepts are connected and then using those relationships to find the answers.
So instead of reading and understanding text, the AI is basically exploring a map and following the paths between different pieces of information.
That is a great way to put it. And 2 Wiki Multi-Hop QA really tests how well AI models can do this kind of graph-based reasoning.
That makes sense.
Yeah.
So how did RoseRAG handle this change, going from text-based to graph-based reasoning? Was it able to adapt?
It did amazingly well. And this was one of the things that really impressed me about this paper.
Yeah.
The fact that RoseRAG did so well on both HotPot QA and 2 Wiki Multi-Hop QA really tells us that this is a flexible and adaptable framework.
That's a big deal. So it's not limited to just one type of reasoning or knowledge base. It can be used for all sorts of problems that involve connecting the dots between different pieces of information.
Exactly. It's that versatility that makes it so exciting from a research perspective.
Right.
It opens up all sorts of new ways to make AI models tougher and more adaptable to different reasoning tasks.
Okay, we've talked about multi-hop reasoning in both text-based and graph-based settings, but I think we saved the best for last. Let's talk about strategy QA. This is where RoseRAG really shines and shows its ability to think outside the box. You ready to dive in?
Let's do it. Strategy QA is a really fascinating data set because it goes beyond just retrieving facts. It's all about strategic thinking and common sense reasoning.
So it's testing whether the AI can actually understand the information it's given and use it in a smart way.
Exactly. So with strategy QA, it's all about, can the AI think strategically?
So it's not just spitting out facts, it has to come up with a plan to answer the question.
Right. The questions in strategy QA, they're often very open-ended. So the AI has to look at things from different angles, try out different approaches, and sometimes even just make a good guess when it doesn't have all the information.
It's like the difference between following a recipe and creating a whole new dish.
That's a great analogy. And to make it even more challenging, the documents they give the AI don't always have all the answers.
So it's not enough to just find the information, you have to know how to use it, even when there are gaps or things that don't quite add up.
Exactly. The AI has to be able to sort through everything, figure out what's really important, and then use that information strategically to answer the question.
Okay, I see why strategy QA is such a tough challenge for AI.
Yeah.
But you said RoseRAG did really well on this one. How did they manage to make that happen?
Well, the researchers actually made a few tweaks to the RoseRAG framework specifically for strategy QA.
Okay, I'm all ears. What kind of tweaks?
Well, they realized that for these kinds of strategic questions, sometimes the AI needs to go beyond what's in the documents. It needs to tap into its own internal knowledge.
So it's like they're giving the AI permission to say, hey, the stuff in these documents isn't enough. I need to use my own brain power here.
Exactly.
Yeah.
They added a sort of backup prompt that encouraged the AI to think strategically and leverage its internal knowledge when the initial reasoning process just couldn't come up with a definitive answer.
So they're combining retrieval-augmented reasoning with the flexibility of the AI's own knowledge.
Precisely. And this hybrid approach seems to be what gives RoseRAG the edge on strategy QA. It's not just about retrieving information, it's about knowing when to retrieve and when to use what you already know.
That's really fascinating. So the future of AI, it might not be about building models that know everything. It's about building models that can learn and adapt to new situations.
I think you're right. And the results on strategy QA really support that. The fact that RoseRAG can handle these really complex questions, the strategic ones, it opens up all sorts of possibilities for using AI in different applications.
It makes you wonder, what if we could have AI systems that can help us solve problems in healthcare or finance or even climate change by using this combination of external knowledge and strategic thinking?
Those are some really exciting possibilities. And the fact that RoseRAG can do all this with smaller, more efficient models, it just makes it even more promising.
It feels like we're moving towards a future where AI is not only smarter, but it's also more accessible to everyone.
Absolutely.
Well, I think that's a great place to wrap up our deep dive into RoseRAG. We covered a lot today, talking about its framework, its impressive results, and how it might just change the future of AI.
It was a great discussion.
I always enjoy these deep dives, and I hope our viewers do too. Thanks for tuning in, everyone. And remember to keep exploring this incredible world of AI. Until next time, stay curious.